Hey everyone, it's Bradley Bush with another algebra video for you. Today we are talking about rational expressions. How do you add and subtract them? Thanks for coming to my channel. If this is your first time, thanks for finding me. I hope you enjoy it and I hope you come back. Let's get started. So the question is, how do you add and subtract two rational expressions? If you're not sure what a rational expression is, you can check out the video on my YouTube channel about rational expressions. But the short version is they are fractions with polynomials in the top and in the bottom. So to add two rational expressions, if they have the same denominator, meaning the same polynomial in the bottom, then you simply just add the numerators, just like you would a normal fraction. If they have different denominators, then you first have to find the least common denominator and then convert both of the expressions so that they have the same denominator, just like you would when you're adding two fractions that don't have the same denominator. And then you can add the numerators from there. If you're subtracting, then you first distribute the negative through each of the terms in the numerator of the second expression, meaning you're subtracting two things with a negative in between the two things. That's what you're distributing. And then it becomes just an addition problem. And so you can just add as you would normally from that point. So let's do some examples. Add or subtract the following rational expressions. This is example A. Before we do that, so 5 over x minus 1, that's our first rational expression, and we're adding 3 over x plus 1. Before we do this, let's do a quick refresher of fraction adding. So if you add 2/3 and 1/3, notice they have the same denominator, 3, so we can just add the tops. So we add 2 plus 1, and it's all over that same 3, which gives us 3 over 3. But if we happen to be adding two things that don't have the same denominator, like 2/3 and 1/2, one has a 3 and one has a 2 in the denominator, then we have to get a common denominator, right? So we can multiply the 2/3 by 2 over 2 and the 3 or the 1/2 by 3 over 3. That gives us 6 in both of the denominators, and now they've got the same denominator, and we can just add the tops. 4 plus 3 is 7, so we get 7 over 6. So that is exactly what we're doing when we're adding and subtracting rational expressions. It's just that we aren't dealing with just numbers anymore. We have variables that are thrown in there. So it's a little more complicated, but the process is identical. So that should give you some hope. If we look at these two, 5 over x minus 1 and 3 over x plus 1, we look at the denominators, x minus 1 and x plus 1. They're not the same, so we've got to get a common denominator. So if I write down over here the LCD, it's going to be just x minus 1 and x times x plus 1, because we don't have anything in common between the two. So now we have our LCD. For example, back here 6 was our LCD, and we multiplied 2 by 3 to get 6. We need to convert both of these denominators into that common denominator. So I'm going to multiply the left one, 5 over x minus 1. We're going to multiply that by the one that's missing, so x plus 1. And what we do at the bottom, we're also going to do the top, so that we're in effect multiplying by 1, which doesn't change anything. And on the right, we're going to multiply by x minus 1 over x minus 1. We can distribute the 5 to the x and the 1, and from the first term, and the 3 in the top to the x and the minus 1 in the second term. And if we rewrite all of this, then we have 5x plus 5. And this is, that's not a very good line. See if I can do, okay. That's not much better, but we're just going to have to leave it like that. X minus 1 and x plus 1. And the left, or the right term is 3 times x, which is 3x. And then minus 3. That's a little bit better. And we have x plus 1 and x minus 1. Wow. I'm struggling with my handwriting. Now we have a common denominator, which is x minus 1, x plus 1. And we can simply add the tops. So all of this is going to be over the common denominator of x minus 1, comma x plus 1. And we'll have a long division symbol. And we have 5x and 3x, which give us 8x. And we have 5 minus 3, which is 2. And we are done. Our next example is example B, which we're subtracting two rational expressions. The first one is 5x plus 1 on the top and x squared minus 9 on the bottom. The second one is 4x minus 2 on the top and x squared minus 9 on the bottom. We look at them and we're like, sweet, that's kind of nice. We have the same thing in the bottom for both of them. So we can simply just distribute the negative and simplify. So we have 5x plus 1, and we have minus quantity 4x minus 2, and this is all over x squared minus 9. So let's distribute that negative, and that gives us, we have 5x, let's just write these down so we don't forget them, and we have negative 4x, because the negative and the positive make a negative, and negative times a negative 2 gives us a positive 2. So we're getting close to being done here. We have 5x and 4x, which give us 9x, and 1 and 2, which give us 3. And we get x squared minus 9. Well, that's a terrible 9. So we look at this and we think, can we simplify it all? If we pull the 3 out of the top, we get 3x plus 1 and x squared minus 9 factors into x plus 3 and x minus 3, which nothing simplifies there. So we're done. Let's do our next one. Here we have example C, which is we're subtracting two rational expressions. The first one is 3x over x squared plus 3x minus 10, and the second one is 2x over x squared plus x minus 6. They don't have the same denominator, so we need to get an LCD. We need to get a common denominator. And we don't know what that is yet, but we can find out. And we can do that by factoring. The left term can factor into x squared plus 3x minus 10 can factor in. We need factors of 10, negative 10 that sum to 3. So that would probably be x minus 5 and x plus 2. I take that back, those signs are wrong. X plus 5 and x minus 2. That'll work there. Let's look at the expression on the right. Factors of negative 6 that sum to 1. So probably x plus 3, x minus 2. What do they have in common? They both have an x minus 2. So let's write that down. They both have an x minus 2. That took care of this term and this term. But one of them has an x plus 5. So we'll include that. And the other one has an x plus 3. We'll include that. So there we go. There's our common denominator. So we're going to need to convert both of these, the left and the right, to have that same common denominator, and then we can distribute the negative through, simplify, and we'll be done. So if we look at this first term, the 3x over x squared plus 3x minus 10, we can see that we're missing the x plus 3 term. So let's add that. And when I say add, I mean we're multiplying by x plus 3 over x plus 3. And we look at the second term and we're missing the x plus 5 term. So let's make sure that we multiply x plus 5 on top and bottom. And my x didn't look so hot. All right, we're getting close to making some progress, I should say. Let's just rewrite all of this. So if we distributed the 3x into the x and the 3x into the 3, we would have 3x squared and 9x. And in the bottom, we're going to have x minus 2, x plus 5, and x plus 3, our common denominator, right? Our next term will be the 2x multiplied by the x and the 2x multiplied by the 5. Let's put that down. So we have a negative, and then we have 2x times x is 2x squared. 2x times 5 is 10x. And this is again over all of this common denominator. And I'm just going to copy and paste it. So we're getting close. We're really getting close. We need to distribute this negative, right, through each of the terms on the right, and then we can just collect our terms. So we have 3x squared. We have 9x. The negative times the 2x squared gives a negative 2x squared. And the negative times the 10x gives us negative 10x. And in the bottom, we have our same common denominator. Let's collect some terms. We have a 3x squared and a negative 2x squared, so that just gives us a 1 positive x squared, and we have 9x and negative 10x gives us negative 1x, or just negative x. And in the bottom, again, we have our common denominator. Can we simplify it all? If we factored an x out of the top, we'd have x times x minus 1. Unfortunately, we don't have an x minus 1 in the bottom to cancel with that. That would be great, but we don't have one. So we're done. Our answer is x squared minus x over that common denominator of x minus 2 times x plus 5 times x plus 3. Let's move on to our next one, example D. Example D, we have 7 over 5x squared plus 15x, and we're adding to that 9 over x squared plus 6x plus 9. They don't have the common denominator, so we're going to have to find an LCD again. And we need to factor these. If we factor out a 5x from the denominator on the left term, we get x plus 3. And if we factor the right term in the denominator of the right term, we get x plus 3 and x plus 3. So they both share an x plus 3. That's for sure. Let's write that down. And the left term has a 5x that the right doesn't. And the right just has x plus 3. So we found our LCD, which is x. Whoa, wait. We need 2x plus 3s. So let's put a square. Because the right one has 2 and the left one only has 1. So we'll have 2x plus 3s and then multiply by 5x. So if we look at the left term, the denominator has the 5x and it has one of the x plus 3s, but we need one more. So we're going to have x plus 3 and x plus 3. We're going to multiply those by the top and the bottom of the left term. And as we look at the right term, we have 2x plus 3's, but we don't have the 5x. So we're going to multiply by 5x in the top and in the bottom. We can distribute that 7 through the top of the left term, and let's see where we are now. So 7 times x is 7x, and 7 times 3 is 21. And we have our common denominator, which is, we'll have 5x there, and then we have x plus 3 times x plus 3. I'm going to copy that because that'll come in handy. We also have our right term. 9 times 5x is 45x. And in the bottom, we have our common denominator. Now we have a common denominator, and we can simply combine the tops, which is not too bad, right? We have a 7x, and we have a plus of 21, and we have a plus 45x, and all of that is over our common denominator. We have 7x and 5x, that's 52x plus 21. And in the bottom, we have our common denominator. All right, we're done with that one, at least. Oh, I need to change that kind of looking box thing to something more bright. There we go, orange. Last problem. This looks a little crazy, right? We've got 3 terms. The first term is in the top, we have 4x squared plus x minus 6. In the bottom, we have x squared plus 3x plus 2. And the second term, we're subtracting the second term. The second term is 3x over x plus 1. And we're adding the third term, which is 5 over x plus 2. So they obviously don't have a common denominator. So let's find one. And we'll treat 3, adding or subtracting 3, just as we would 2. We get a common denominator, distribute a negative if we need to, and then combine the tops. So first I need to factor the bottom of the first one. That looks like it's x plus 1 and x plus 2. And luckily for us, those are the exact terms in the denominators of the other two. So we'll just use that as our common denominator. X plus 1 and x plus 2. So if we look at the second term, it's missing the x plus 2. So we'll make sure we fix that. And the third term is missing the x plus 1. So we fix that as well. Nice. We need to distribute the 3 to the x and the 3 to the 2. We'll also distribute the 5 to the x and the 5 to the 1 on the third term. Let's see what we have here. We have 4x squared plus x minus 6, and that is all over our common denominator of x plus 1 and x plus 2. I'm going to copy that because we will need it. Then we're subtracting 3x times x is 3x squared, and 3x times 2 is 6x, and we have our common denominator in the bottom, and we're adding 5 times x is 5x, 5 times 1 is 5. And again, we have our common denominator. We're close. We're really close. We need to distribute that negative through the two terms in the second expression. So we get negative 3x squared and negative 6x. But we can write everything now over one term. So we have 4x squared plus x minus 6 minus 3x squared minus 6x plus 5x plus 5. And this is all over our common denominator. Let's see what we can combine. 4x squared and negative 3x squared gives us positive x squared. And that gets rid of that term and this term. Let's see the x's. We have x and 5x, which is 6x and negative 6x. All the x's cancel out. Well, that's nice. And then 5 and negative 6 give us negative 1. And the bottom we have x plus 1 and x plus 2 again, our common denominator. Here, finally, we can simplify something. Because x plus 1, or x squared minus 1, excuse me, x squared minus 1 is the difference of squares. So we can factor that into x minus 1, x plus 1. And this is all over our common denominator of x plus 1, x plus 2. So notice the x plus 1s can cancel. I'm glad we finally got one example where that happened. X minus 1 over x plus 2. And we are done. Hopefully this was helpful. Thanks for watching. Have a great day.